evening. With a change of topic from a very deep optimization algorithm to a very bird-eye concept on introduction of a topic rather, which is human-computer interaction. And I'll bring a serious note to it by saying it is meant for disabled people. So I've added the word. The topic is human-computer interaction for disabled people, wherein we at CSIU specialize for disabled people interaction with machines, interaction with computers, and my personal experience has been with blind people. So you'll see some touch of human-computer interaction devices for the blind. With the overview of the plan of presentation, give importance for the subject, that is human-computer interaction, so that one gets familiarity with the subject, and also bringing in the human element to the whole interaction, that is capability of the human beings. Human beings as a mind, as a cognitive capability. And then interaction, the primary interaction comes from the devices. As you will see, as I mentioned, the devices for blind. So we'll have devices which are changing with time, newer and newer devices are coming up. And we have further focusing on to the main topic, as I mentioned, human-computer interaction and assistive technology, as we call it, for the disabled. And finally, we have conclusions. Primarily, as you will see, it talks about interfaces and interaction styles. So new devices, technology also comes into the play. And the overall objective is that we make the human life simpler and easier, at the same time more productive. So it has a proficiency as one of the objectives. Again, it involves the study of humans. So a lot of human aspect into the capabilities of human mind and the technology giving interfaces. Development of new applications. You find with the newer and newer devices, you have now walk-in ATMs, you have mobile devices, you have miniature mobile wearable systems. So you find that new applications and new devices go together. So that is also the reason that HCI goes on to generate newer concepts. So devices and tools with users in mind, as you can see here. Again, the question comes why. I gave some importance on HCI. It's, as I mentioned, the importance needs to be understood by the new applications, the users and their activity to have productivity and safety. So I gave earlier utilization of such devices, new concepts into disabled life. At the same time, their safety, of course, is visible. Even in situation like flight simulators kind of software designs, wherein pilots are getting trained. So the human-computer interaction provides how the safety brings in their proficient lifestyle. Okay, another reason why we go for HCI is, I'm quickly giving the point here, that there is a lot of ubiquity of computing. That is, now it's becoming computer everywhere. So once it is becoming like that, so naturally humans are becoming, or computers are rather becoming as populated as humans, so interaction has to be obviously there. So one must have newer and better ways of having interaction. So that brings one more reason for why HCI. So also to bring in here the virtual reality, as many people may confuse it with that, is virtual reality is just the other way around, wherein we bring people to the inside world, to the virtual world, while here the computers are into the real world. So that's another difference here. And continuing with it is again why HCI. If you see a particular system code, you will find that a lot of code goes into this interface part. Many of you may not feel that when we discuss the algorithms and the functionality of the system. The overall system, when it comes to the reach of the users, the buyers, the application users, it takes a lot of further code. As you can see here, maybe surprisingly, the functionality of a system just goes by 30 to 40%, as you know, in the pass marks kind of percentage. The 40 to 90% code goes with the interface. How the user interfaces it. The GUI, the older way of saying the same GUI. And most typical estimates are about 70%. So you can imagine it's 30-70. The 30% goes for functionality of the system and 70% goes for the interaction part. So it's very complicated, you can say, or cost wise, if I say, the code cost goes as that high as that. And if it is going wrong, if a particular product doesn't find acceptance by the users, then you have to redo it. It's like getting a thing tailor-made. So it's like user-centric design that we really consider her. Typically giving you a feel of it, that different users will require different kind of interface. This is not something that I'm going to discuss what it is. I'm only going to tell you that it is a system which is PC based, but there's nothing like file, edit, view and things like that. There's no GUI of that kind. This GUI is meant for, just for your information, to compare rubber quality on a system which is automatically having an algorithm for grading the rubber. So therein left. So I'm not going to the detail of what it is, but only I'm trying to say that it's an operator driven machine for rubber grading. The user is going to put a rubber sample and getting a grade out of it. So the interaction is not based on the routine style of file, edit, view kind of the interactive software that we make. Now also going to why is this topic becoming so important? Many times I really put a very analogy to it that designers many times, because the number of computers are high, the number of designers also, if I can say, as a hobbyist, everybody trying to design a software, many times it is becoming designers building for themselves. So and ultimately you find that products in the market or products at the user level are very number. If I ask you how many mobile manufacturers in the world, you will not be able to say more than 5. But or if I say if everybody is making software as a project in an M.Tech or B.A. Tech, why are there not so many products available? Why there are not many software operating systems available? So the idea is, many times if I give an analogy, it's more like bathroom singles. So we are making things for ourselves. It doesn't reach the user. So that's the point number one here. Designers build for themselves. Also, as I said, becoming individual centric. We are not considering the users and tasks and organizations into the picture. If a particular system is to be made, it is meant for a particular organization or an individual and their task efficiency, which is to be improved. So basically, there are poor understanding of the problem, the people, and definitely, obviously, the solutions. Giving another feel of an interaction that we have in a system, which is now real time. Somebody raised a question on real time. Now, the real time system cannot have again the interaction same as an offline expert system meant for, say, medical diagnosis. Now, in this case, the system is directly showing, it's an intruder detection kind of system that we have developed. Herein, the intrusion detection has to be shown real time. So the perturbation values shown here are more like an oscilloscope. So the interaction is obviously very different than any other, closely working system like this. If one is doing here it shows the picture of rice grains measurement, wherein we classify rice. It's an offline system which is very different than an online real-time application that I just showed you. So as you can see, the screens showing the behavior of the interaction. Coming to somewhat, now the core, if I say the word here is human. Now humans are into various categories, though it may be surprising for you that we are talking technology, interaction and all. But as I mentioned, the topic says human-computer interaction. So definitely the human psychology, the user mental model comes into that. So if I just put in the number of classes that humans can be put in, you will find the first simply says them into age and sex. And then you have different, further user classifications, students, customers and all. Now particularly if you are holding a bank account, it's a different user. If you are going to the same bank account with an ATM, you have to prove your identity. If you are using music lovers, you will have different kind of applications. You have iPods. So the point is that different devices, different users at different times are having different kind of interfaces. So that is the idea. Then who is the user for any development that we are going to do? That is the key question every time we must keep in mind. Okay, to bring you now the engineering aspects, it doesn't have merely the electronics engineering, of course, remain the major center of many newer products, but engineering in general. So when the product design comes, there are definitely other branches of engineering. And as I mentioned here, it does have a human element, so it has cognitive psychology, the cognitive science and engineering, which is very much related to computer science, ergonomics design, and of course artificial intelligence. Many of you are already familiar, and not leaving the issues like sociology and other things as well. So it is giving a broader perspective that human computer interaction doesn't narrow down itself to certain very specific engineering areas only. So it goes beyond. Although as a subject it is covered as a software engineering and definitely a branch of computer science. So as I mentioned, so though it has been in the past, as you can see, the formal name and definition has come recently. Okay, human processor, as I mentioned here, briefly to give you that human do not perform as fast as machines. So it's a very different. Now on one hand we have so-called a very high-speed machine, a computer on one hand, and the other hand we have a human being who is very different. Depending upon the application, human being is interacting, expecting the machine to respond, and the machine is expecting users' desires and commands. So definitely the two have to work in a very different perception. The machines have a different perceptions and the human processor. Now surprisingly you may find the term here, I am calling the term as human processor. So human mind. The perception system will have a visual thing like seeing. It may listen to we may listen to something if there is a beep or anything, and there is sometimes a tactile touch screens are there. Sometimes you will find there are artificial nose, artificial tongues are available, so you will find even machines can provide smelling and tasting, and then human acts on it. Based on what the machine is responding, the human acts with his motor system or her motor system, and behind that, as I mentioned, the cognitive system of how the user has experienced in the past, learning, reasoning and problem solving. So these are somewhat the, you can say, building blocks for the human mind. Now also giving you a feel of it, the human perception is as slow as 50 to 200 milliseconds in terms of perceiving what is happening around. Not better than that. In comparison to machines, it may appear slower. And cognitive system again goes in the similar range, 25. And the action that a person makes after looking at, it's like when you go to ATM, how you act. You insert a card, then you act. So your motor system will act accordingly by that duration. So now coming to further core technology issues, we have various ways of generating that interaction. Many of you are aware that GUIs are now already standardized for all those things, but newer things are also using icons and symbols, and text is already there. Now you're getting videos also available in many situations. There are tactile sensations, as I already mentioned, particularly when I bring some discussion on blind, we'll find the tactile sensors, the touch screens are already there. So these artificial, other than visual and audible methods are becoming more and more common for interface. Coming to now the core technology, that is what we say as new technology, that is new techniques, new devices, generating new perception capabilities, because somebody say, what was happening without mouse? What would happen if there are no touch screens? What would happen if there are no joysticks? So these are basically indicators of how the devices generate the new concepts of HCI. So it's basically HCI terms goes as if in a layman way I can say HCI talks about the software aspects, and the technology and assistive technology, as I mentioned earlier, or devices talk about the technology or hardware aspects. So HCI attempts to study new modes of communication. So the interaction means the communication between the two, which could be used for improvements in the overall quality, productivity, as already mentioned, and to develop devices and techniques to use these new modes. Now you will see what modes means. Different devices generate different modes, as we will see. One of the mode is like you could also interact with the machine by way of talking. If you could dictate, many of you or otherwise who are disabled do use this voice input output. So definitely the machine can use and has to have now natural language. If you are speaking on the machine, with the machine, you would like it to be natural language, your own mother tongue probably. So that is where the new interaction comes automatically. The machine also needs to have recognition capabilities, as you can see here. So speech synthesis, speech recognition become the two common signal processing as far as the voice input output is concerned. I was talking about tactile, a braille like that, which shows here a device which is to read a line of characters by a blind person, wherein the soft braille. This device is more like a soft braille, wherein the particular characters gets embossed on that particular display here. It's looking like a piano here. This area shows that it's like an each braille character. That's the way the electromagnetic, activation comes to show a particular character to be read by the blind. Giving you a feel of now newer technological devices by way of what is available, and obviously the system accordingly changes the interaction styles. If you see the top, we have a wearable machine which is more like a mobile, you can say, which provides you news, email, voicemail, etc. So as probably nowadays it's all common to you even in mobile devices. A watch there which can measure your stress. More interestingly, you have a locket kind of camera which, when you open up, has two LCDs to give you pictures that you have taken. And lastly, we have a device called head-mounted display. Now, if you are aware, head-mounted displays were two goggles-like displays wherein you were, watching any videos. So this device has come as a single device, wherein they say you use one of them and the other eye is still available, and give you a feel of 28-inch monitor. Imagine 28 monitor display. The idea is that with such displays, or with mostly they are display or input devices which generate newer. So when there are wearable technology coming up, you will have different interfaces. No one will have a keyboard mouse kind of interface. Okay, now coming to the somewhat serious aspect, or I would say the sensitive aspect of using such technology for the disabled. Disabled need more technology, more inclusive technology, rather than having separate words for them. So that is the idea, particularly when you find that 10% of the whole world does fall into this category, and in India we have large number of such people. So the idea is that not to have separate word for them, but to include them, what they call inclusive technology. And as I already mentioned, products here are very badly designed, sometimes not taking consideration of the blind or any other disabled. Giving a feel of Stephen Hawking, the very renowned physicist with a lot of disability. A lot of research funding has been put on it to give you a emotional touch to the work. That rehabilitation of people like him and many other does require technology, does require newer method of interaction. In this case, you can see the speech therapist. There is a combinational, it's a total interaction where his keyboard is visible to the speech therapist. He can speak at some level, or he can. There in another diagram you will find similar system giving the latest look wherein the person is able to press a particular key. So the idea is that we have to improve their way of life, their quality of life, by a way of improving the devices, improving the interaction. So rehabilitation technology, or RT or AT or assistive technology, these are the terms used in general. So giving that kind of feeling in your mind, giving you further on our kind of area wherein visually impaired are our focus as such for the present research projects. What happens to blind then? We have a blind school nearby here. How are they affected by the technology? How can their life be changed? So primarily, if you see, their needs are the real world, that is when they move out. What they do, they may be using sticks only, or their others help. But as you will see, some of the applications who have targeted real world recognition, so that they can move out in an office, in a open area, or in a navigational manner, that they know what is what. There's no, basically the obstacles that they find in the navigation during their path of navigation. So systems should help at that level. The other is that their mind. That is how they can improve their knowledge, their information. So information access is the second area. So though our work has been more on the information access, as I mentioned, reading devices for the blind, there is some material that I would show about the real world recognition that has happened in the world. Something to show you that stereo vision cameras are available, as you can see on the right there. Exactly similar device we have used for reading also in our application. Herein it shows what mobile robotics, mechanical engineering, automation and other control system areas have already worked with, that is using mobile robotics technology for helping the blind. So in this case it shows real-time image processing for a stereo 2-eye kind of imaging system, wherein here if you see the left image for a scenario, the right image for a scenario similar to what human beings see, and the depth information available here. The brighter shows the nearer objects and the darker shows the farther objects. So it's a range image, as we call, or disparity image, based on if this is the left image. As you can see, the left image and the right image are not exactly same. So that's how we perceive depth. So stereo vision provides the depth information, and then we need to apply this with a mobile robotic situation and give them a navigational speed, navigational guidance. So you will see that spatial and navigational guidance along with other modes, like giving them a feel of force feedback if they are doing something, if giving them a synthesized speech if they are going wrong somewhere, giving them a tactile sensing if something is coming, if sometimes it may be like something hot or something otherwise dangerous. So basically the idea is that giving them a lot of sensation by other than eyes, other than the visual means. So giving you a feel of it, a system like that, what I just mentioned, a project here called PAM-AID, where personal adaptive mobility. Though such things may appear very costly or not so easily available, but the world is trying to include people with age and other disabilities by such devices, wherein you find that there are technological devices similar to what they use in mobile robotics. Mobile robotics, they have autonomous mobile robots. So they move around. So in this case, what they do is they add some assistive aid, support aid, so that the blind can move with the device. Another similar device wherein you can see it really goes for structured indoor environments as well. The person with such a device, it's again a mobile robot, as some of you might have seen. It has a range finder, laser range finder, it has ultrasonic range sensing, it has a camera, it has RFID to know which office is available. RFID detector provides, it's like giving them exact information of what office one wants to go or where one is. So they add RFID as well. So the idea is to give them a feel of it. Now coming to the last aspect of my presentation, wherein I give how blind people can access to newer materials, newer information or knowledge domains, study material and other things. So the basic concept here for all these reading machines is that they follow non-braille, that is routine text that you and me all read, the material on printed text, the books, the documents, the magazines, and if possible we may try even the newspaper. So we use a scanning device which images the document of interest and use the standard technology of optical character recognition for reading and text to speech for speech generation, or soft braille, as I showed you one device for braille as output. So the idea is that this is the processing element. Now what is the technology here? The technology is PC, the PDA, the mobile, the laptop, the mobile, even the mobile devices are now getting the software with all these capabilities. So you will see some examples here. Going a bit of history which I can skip quickly but give you a feel. I'll come back to what I said about reading devices, that in the past with when such technology was poor, so the interaction styles were poor. The person was holding something magnifier on a monitor like TV to visualize the characters written in some bigger visual form. So naturally the interface was different. Imagine a flexible fiber bundle like way of interacting where the user would move around with that flexible cable to see what is written in the book when there was no technology, just merely optical technology. So with the further changing technology, a person would like to read. This is not exactly meant for blind, but it uses the same approaches, a handheld device to read somebody's number, somebody's telephone number, name, etc. from the telephone directory. So since the principle used is same, it's another device more like a mouse, wherein at the bottom it has again the imaging device. So it moves around the document to give you a feel of it. But most of them are meant for not for the totally blind people. They are meant for partially blind or where have some visual difficulties. So giving you now the latest scenario, the latest technology basically goes into two categories. One is that we use tabletop approaches. Use the office scanner. I have already given the principle. Put a document the same way. Now imagine whether blind people can do it or not, the interaction that he will face. But yes, these devices are presently available. The user has to place the document with some help if required. Otherwise, this much they can easily do without any problem. And most of them, they all look like a scanner with coupled machines somewhere to process into speech form. So most of them are all reading devices to generate speech form. And they all read whole document at once. So they are portable, not really portable, they are tabletop kind of thing. Now the latest. The international scenario now says, here is one mobile eyes wherein a camera is attached with the mobile PC. So the mobile laptop basically. So you have a moving, what they call is mobile eyes, and exactly it is not a mobile, but it is a laptop attached, a small laptop. So it provides you almost the same thing, including navigation where you move around. Certain things like you want to read currency, you want to see any obstacles. So some level of help is there. Now for information access, these are the devices. Kurzweil, who developed the scanner, is having a national foundation. So that is KNF reader device. This is the device which came earlier wherein a camera is attached with the PDA. Now the problem with all these devices is that user has to stand on the document because they are portable. So user has to stand on the document, find the document place, and though there is a speech guidance, the device does provide whether you go up or down, and then the whole document is snapped to give you a reading device. So you have a mobile version of that now in Nokia. That software can be added. Now coming to what we have done, which is slightly different than this, wherein a device like this, which is handheld but not really portable, it is portable but not really mobile yet, is providing a complete reading at your ease, giving a particular paragraph only at a time. So it gives a motion in steps. That's why we call it step scanner device. It uses a similar twin camera, twin imaging module, or even a single module device to acquire picture of the document of a paragraph completely up to the width, panoramic view of the paragraph, and then giving the rest of the principle as I already mentioned. So it gives exactly what it is now. So presently we have also brought in what we call biscuit PC. So a mobile PC like embedded PC is now being integrated with the device to have the processing right on the top. So this device has now reached a portability level wherein it is not yet mobile but portable, with the extent that you can carry it to the blind person can carry it with the same level of but the advantage is that it has a step scanning, that is at a time it has a quicker response, just reads a paragraph at a time and then goes on to read further. So giving you now the final conclusions on assistive technology, human computer interaction, and the people, that is the disabled. So the issues here are, to summarize, are we really making them equal or inclusive in access? Are there any limitations that sometimes we find that no, with a certain limit only the technology can help. The blind or any disabled, naturally disabled person may not be able to do exactly the same work, but that is somewhere a doubt you can say, but that's what we are trying to raise an issue, whether there are any limitations Are we reaching them with the devices? The technology is there on one hand. Are we reaching them? Are they able to appreciate? Are they able to approve them for their lifestyle? Also, for the country like ours, wherein we do find the national scenario very different than international scenario, as you can see by the level of attempts made in the global world. Also, as I mentioned, once we talk of multimodal devices, wherein a lot of language support is required, so we need to have all languages. Once we have people to help them, they have to be, once a person is disabled, he cannot learn English or any other foreign language at this moment. So there has to be a total language support. So we have to do a lot of language. There is a technology development in Indian Language Board in DIT, Department of Information Technology, that is already working on it. But that's the point I wanted to bring here, that we need to have total language synthesis, language recognition kind of work here. Can we measure the effectiveness? I missed some of the points here which I could have discussed. This is how to evaluate HCI. So there are ways of evaluating, but the idea is, can we find their evaluation and effectiveness so that we go on in the same direction. It's like whether we go in the right direction or not, so that a particular technology, particular approach of interaction can help them properly. Also, are we involving them in our discussion? Many times, though this forum is not meant for disabled only, but I am saying whenever we do this development design, if we don't involve them, their design quality will be poor. Also, a serious thing that we have mentioned, the technology cost. Very heavy cost comes into the technology. As you can see, mobile robot technology made available to an individual, one cannot imagine the cost. So is it a profitable proposition to an individual, to an industry that can provide such devices? Is subsidy an answer? There are so many questions I have already put here. It's really meant for all of us to see whether we have answers for these or we still have more issues. Thank you.